All right, number 14, we want to verify the point lies on the curve and then determine the equation of the tangent line to the curve at the given point. So first part A says verify that the point is on the curve. Evaluate x cubed plus y cubed for x equals 20 and y equals 20. So we have this expression. We have x cubed plus y cubed equals 40 xy. And then we're just focusing on the left side. We're going to plug in 20 to give us the ordered pair 20, 20. All right, so we're going to plug in a 20, raise it to the third, plug in a 20, and raise it to the third. And in doing so, you get 8,000. So we get 8,000 plus 8,000. That gives me 16,000. If we evaluate the right side, 40 times 20 times 20, and see what that equals, does look like we should get 8,000 again. But just for good measure, 40 times 20, or 16,000 I should say. We do get 16,000. What did I do? All right, so that kind of verifies that the point is on the curve. Both sides are equal. So it says, does the point lie on the curve? Yes. The point 20, 20, that is. And so now we want to write the equation of the tangent line at the point 20, 20, and we're going to select the correct answer below. So it says the point does not lie on the curve, which we just proved it does. So from here, we're going to find the derivative. And so I'm going to move everything to one side. X cubed plus y cubed. I'm going to subtract that over, so it's going to be minus 40 xy equals 0. And we're going to find dy dx, that's our standard derivative. Using our shortcut, that is equal to the negative partial of x divided by the partial of y. So however you set your derivative, I just flip those two terms and you'll get what you need. All right, so I'm going to do the derivative of this function treating y as a constant. So it's going to be treated just like a number. So we have a negative derivative of x cubed is going to be 3x squared. Multiply and subtract 1. Derivative of this is going to be a 0 when we're talking about x, so that's 0. And then derivative of this term, so if you just focus on the 40x, it's just going to give you a negative 40, but the y is treated like a constant, so it'll be a negative 40y. So minus 40y. Now this is a negative, so that negative actually distributes to both and could change both signs, but I'm going to be careful right there. Then on the bottom, we're going to do the partial with respect to y, so that would be 0. Derivative of y would be 3y squared. Derivative of this term, kind of ignoring the x, will give you a negative 40, and then negative 40x. So. All right, so here is our derivative. Once we find the derivative, we have to plug in the order pair 20, 20 to get the slope. So we get negative 3 times, I guess I should be careful. This is 20 squared minus 40 times 20. squared minus 40 times 20. Now, if I distribute this, this will be negative, this will become positive. And if you look at these very closely, it's pretty much the same term. This matches this. This matches this. So whenever we do the work, we're going to get the same number. One is going to be negative, one's going to be positive. So without even doing a lot of work, this looks like it's going to be equal to -1. Okay, because you're dividing by itself, just opposite signs. So my slope is -1. Having my slope, we're going to do y minus y1 equals m times x minus x1. To write this in slope-intercept form, both the x and y1, the order pair are 20, and our slope is -1. So I'm looking at y minus 20 equals -1 times x minus 20. Distribute, and we're going to move that 20 over. So we got y equals, this will be a negative x plus 20. And then we'll add that 20 over as well, because -1 times negative is positive, plus that 20 gives me y equals -x plus 40. So this will be the equation of the tangent line through that point.